Hello everyone. So today we'll be solving a harder problem, regular expression matching. The problem states that we are given two strings, input string S and a pattern string P. Now we need to implement regular expression matching with support for dot and star, where like this dot will be matched with any single character and this star can match with zero or more number of the preceding element, and we need to match this pattern in S such that the entire input string is covered. So, and like S and P can go up to maximum of length 20, and S will only consist of lowercase English letters and P will consist of lowercase English letters as well as these dot and stars. So like what does these dot and star represent here? So let's see the meaning first. So for star, what do we mean here? Is that, for example, if we have this star S here, so means A star can be matched to, means this star means matches 0 or more of the preceding element, means for this star the element which is preceding this star we can match it to the given string 0 or more times. So for example, in this case, if we have S as B only, so if we match this, means take it together, match it 0 times, that means this will be represented by empty because we taken 0 A's. Okay, so hence we will be able to match B and B. But suppose this was the case where it was, means A was present 3 times and B was present single time. So we will utilize this utilize this star to, means copy this A 3 times. Okay, so this star simply means like if you have studied theory of computation, so where it represents like this A can be repeated greater than equals to times. Okay, so means this A can be either present 0 time or 1 time or 2 times or so on. So this is like the same concept is being asked here, like this A star can represent means empty string or A or double A or triple A and so on. As you can see, like if we use A star as AAA here, then we'll be able to match this pattern to this given string. So I hope like the meaning of A star is being clear here. Now what does dot mean? So for example, if we have AB and we have dot B, so this is the pattern and this is the string. So this dot means it can be matched to any character. So if we, even if we had like AB or BB or CB till ZB, this can be matched to any character. Hence we'll match this with the first character, and since second character is already equal, so hence we'll be able to match the given pattern to the given string. Okay, so we just need to like find out whether the matching is possible or not. Okay, this is what we need to do. So for example, now you might wonder like what if we have like star dot and then star. Now this dot can be matched to any character, and then if we have star, so this will mean the same thing. Either we can use dot and means empty times, or use a single dot or double dot and so on. And if we have like this, then this means like this can be matched to any character. So these two can be matched to any characters and any different characters. That means if we have dot star, then we'll be able to match any kind of string, because this dot can be means duplicated any number of times, and hence it can be matched to any of the characters. Hence it does not matter what S is, we will be able to match this pattern with the given string S. Okay, so here we'll be able to like, first we will make 5 dots, and this will represent H, this will represent E, this will represent L, this represents L, and this represents O. So hence we will be able to match this pattern to the given string S. So like I hope now the means how we'll be using these dots and stars are clear now. We can use the star, A star, to represent an empty string, or we can use it multiple times, and for dot we can use, means we can be able to match it with any given string. So let's see the given inputs that we had. So for example, we had AA and a single A. So now we do not have any dot or stars in this pattern, so we will not be able to convert it to AA. Hence this is false in this case. In this case we have AA and A star. Now A star means A can be duplicated greater than or equals to 0 times. So here we will duplicate it 2 times and we are able to match the given string, hence the output here is true. Okay, now in this case we know like dot star means dot dot, and this dot can be converted to A and B, hence we will be able to match the given string in this output. So hence the output here is true. So now let's like once we like try to observe the constraints, we see that the length of both the strings can go up to 20 only. Now what is the sense of giving constraints so less? Means there are only very less possibilities. Like if the constraints are very less, means they are asking you to try to like develop a recursive solution, right? Because a recursive solution of like the order of 2 to the power 20 or suppose 3 to the power 15 14 approximately, so like these will not give you tally. So like this gives us the hint like we can try brute forcing all the possibilities of like matching here, and then recursively try to see whether we are able to satisfy the condition or not. So let's see like what are the different conditions we need to satisfy in a recursive fashion. So suppose we have the given string s which has the prefix till 0 to I, and we have the pattern p which has the prefix till 0 to j. Now initially what we'll do, we'll start I from 0 and j from 0. We'll move these indexes till the end such that like suppose it reaches n and it reaches m, and we are able to like move, if we are able to move both of them to till the end, then we'll return true. Okay, so this is like the general recursion. Now we just need to like identify conditions of how will be what are the different conditions possible on the basis of what we have at the current positions, whether it is like a star or dot or a normal lowercase. Okay, and since we like need to convert this p into s, so we'll be trying to like traverse through this p to like convert it into s and see at each step whether we'll be able to convert it or not. So what are the different possibilities? So suppose the indexes are I and j. So the first possibility can be p of j is same as s of I. Okay, so either this is the same, means either they are AA, or there can also be a possibility like the p of j is dot and this s of I is some character, right? So in this case also suppose like p of j equals to dot. In this case what we will be able to do, like we will be able to match a single character, right? So like let's try to see this condition separately, match a single character. So the first intuition might be like we can solve, initially we'll be calling the recursive function for from 0 0. So we'll call the recurve function for I plus 1 and j plus 1. Okay, you might think like doing this is correct, but there is a fault in this. How? Because suppose s was a and our p was a star. Now initially I was at 0 and j was at 0. So j was at here and I was at here. Now if we match both these two values, then I will move to the next index and j will move till here. Now we see like v s will represent this will be the empty end of string, and we still have a star remaining. We will not be able to satisfy any condition for this star, because for this star to satisfy we need to see the previous element and duplicate it sometimes, right? So if we like use this simple if we simply call this recurve function, then in the next step we will reach like I greater than equals to n and j would have not reached n. Okay, and it will not be the case like we have the j in the form of the remaining pattern in the form of like a star, right? So that we can convert it into an empty string. Suppose it had been a star, b star, c star, so on, then only we can convert all them into empty string and we'll be able to match the remaining j j from the pattern string for the empty because s has already completed. So we know like if we are at this star, we will not be able to do anything. Hence if we like initially do this check and call this recursive function, that will be incorrect, because we need to first account like whether we need to use this if the star is present in j plus 1, whether we need to use it or not, right? Because that is the first step we need to do. Because if we match it bluntly, then maybe in future we will not be able to satisfy the condition for this star. Hence, doing this in the first step is not correct. We need to first check the condition for this a plus star, means the presence of p of j plus 1 as star. Okay, if this is correct, then we need to call the recursive function of this first, and then we'll do the call the recursion for this. So we need to first check for this condition. So what is the first step? We need to see like whether like j plus 1 is a valid index, and what p of j plus 1 should be a star. Okay, so we need to check this. Now there are and it should like, so there are multiple possibilities here. So the first possibility is we use this, we have suppose as a x star. Okay, p of j is some character x. Okay, so now there might be a possibility like we use this x star to represent an empty string, right? Because we repeat x 0 times, so this will represent an empty string. Hence we can like use it to represent empty string. Now that means we'll simply like call the function for so like int, like suppose we skip this value. So skip will be simply recursive function for v, means the I remains at the same position because we have not compared pattern to any string or any character at I, but we have moved j 2 indexes ahead. So j will move to j plus 2. So we'll simply call the recursive function for this. Okay, this is the skip part. Now comes the case where we might need to use it to represent it like x or xx or xxx and so on, right? So we need to do that case as well. So how we'll do it? So like use it duplicate times. Okay, now when we'll be able to use this x star to duplicate? This will only be the case when this s of I is the same as p of j, right? Then only we'll be using it, right? Suppose s of I was a and we had b star, then we'll not be able to match, right? Even if we duplicate b or bb or bbb so on, we'll not be able to match this b to a. So we need to see like if this like p of j should be like equals to s of I, right? This should be the case. This should be the case. Then only we'll be able to satisfy. And we also need to see like this means this I should not have reached the end, because if it has reached the end and then if we simply check this condition, then it will give us some like memory reference error. Okay, because it might be possible like I has reached the end and j has not, but still we can make the j as empty because a star and so on, right? So we cannot simply call s of I at any time. At all steps we need to see like whether I is less than n or not. Okay, so we'll see like if I is less than n and what p of j is the same as s of I, or also there can be case like we have dot star, right? So we also need to account or p of j equals to dot, right? In that case as well we can convert it. So if I is less than n and this condition is satisfied, or like p of j is equals to dot, in that case what we will do, we can like use this dot to currently in the current iteration we'll use it one time. Okay, now suppose in the next step again this recursion will be called. So in this step what we'll do, we'll call recur for I comma means I plus 1, we match this and we keep the j at the same position. Why? Because if you want to use this multiple times, so we keep the j at this position only. Okay, now we'll use this once. Now in second step we'll again use this b. Okay, so if we again call this function, we'll be able to use this 2 times. And now suppose we want to stop at some time, so that condition will be by skip, then we'll move to j plus 2. Hence this skip function will handle the condition where after repeating a certain number of times we want to stop, right? After repeating b or after repeating bb or bbb, we want to stop at a particular point, then we'll be using this skip So and this will cover all the scenarios of empty or using it b times or bb times. So in recursively it will account all the possibilities. So in this case what we will do, if this is true, then either we can call this or means simply return our answer to. If this case is true, then we return or skip, means both the possibilities will be returning. And else if this condition is not true, that means we are not able to make them equal, then we need to skip it only, because if it was a and we had b star, then we need to make it empty only, right? So in that case else we'll simply return skip part. Okay, so I hope like now you understand why we initially rejected this checking first, because we need to, because this check was important first, because we cannot bluntly match the characters, and then analyze the different conditions of when we can make this string, means this characters account as empty, or we can duplicate this x multiple times. So either we will be skipping it or using it if the character is same or p of j is dot. Okay, so this is the case of skip. Now once like if this condition is not true, if p of j plus 1 is not equals to star, then we will be using this condition. This condition of what? If p of j is equals to s of I, or if p of j is equals to dot. And here also we need to check whether I is less than n or not, because there might be the case where I has reached the end and still, means I has reached the end and still we need to compare, means check for j in p, because we cannot like simply in recursive function we cannot simply, if I is greater than equals to n, then if j is less than m, we return false. We cannot do this, because maybe this the remaining part of the means p can be converted to empty strings, right? So for example a star, okay, a star, c star, z star, so all this can be converted into empty strings, right? So we cannot simply do this check in recursion. We need to move j till the end as much as possible. So we need to check at all steps whether this I has reached the end or not. This is like important here in this case, because if we'll simply check, then it will give us a memory reference error, or memory does not exist, okay, or out of bounds error. So yeah, this was the case. Now in else condition we'll be checking this same condition of what? If I is less than n and then p of j is equals to s of I, or if we have what? P of j equals to dot. Okay, this is I should be less than n and then this or this, because p of j should be equals to dot, then we'll be able to match it to s of I, or it is the same. So in this case what we'll do, we'll return recur of what? We will move I till I one step ahead, and we will move j as well one step ahead. And if it is not possible, means this condition is not satisfied, then we will simply return false in this case. Okay, and overall we will be returning false. So this is the the recursive fashion approach for this problem. And as we can see, like at each step what we are doing, either we are like moving I by one step, or moving j by 1 or 2 steps. Hence in the worst case, like the recursion will take what? In the recursion it will take, like since I is being moved by 1 step at each time, and we have like 2 possibilities of like moving it or not moving it. So it will be like 2 to the power I and plus means 2 to the power n plus what? This can be moved 1 or 2 times. So suppose it is like in the average it has like n plus m by 2. Okay, maybe, but it will be like of the order of 2 to the power n plus m only. Okay, so my basically 2 to the power n plus m by 2, because like at each step it will be dividing into 2 conditions. There may be possibilities like j moves by 2 steps. Okay, so this will like give us of the complexity of means 2 to the power n or 2 to the power m by 2. So this is like of the order of 2 to the power n only, or 2 to the power n. Okay, max of them. So hence, since n or m can go up to 20 only, so 2 to the power 20, which is like 10 to the power 6, will definitely work here, because it will work in 1 second. And the recursive space will also never exhaust, because so will not get MLE as well. So I hope the all the why means whys and hows of this problem is clear in this recursive approach. We just we first understood why doing this check initially was not feasible, and then we modified the approach and check for all the possible conditions of making it empty or repeating it m times or just simply matching the current character if it is same or it is equals to dot. So let's see the recursive code for this problem. So this is the solve function. So we have the indexes I and j and the strings s and p. So if j has reached the end, that means I should have reached the end, because we are converting this j means p string to s. So if j has reached end, then I should definitely have reached end. So if I has reached end, then we return true, or if it has not, then we return false. Okay. Now comes the check. So the first condition that we need to do is let's ignore this for now. The first condition that we need to do was the checking of star, a star or not. So if p of j plus 1 is equals to star, so what we can do, either we can do it 0 matches. In that case we'll move j by 2. So this is the case of skip. Solve of I comma j plus 1, j plus 2, and this will be the case of x star, where it is means it is the case where where we are doing it means where we'll check if j plus 1 is less than size and p of j plus 1 is less than star, we'll move it j by 2. And the second condition is this check, the check that we had, like this was the skip case, and the other case is this, if I is less than n and this condition. So we will simply return recur or skip. Okay, so this is what we do. Since we need to check this condition 2 times in the else loop as well, so hence we have defined a bool function to see if the first match is true or not. So we'll move it by one step, or we'll update or with call the first match. If it is true, then call the solve function for I plus 1, means move I by one step ahead, because we have matched the current character and j still remains a star. Okay, and else we'll see this is the character case for AA match or A dot match. Okay, so this is the case in which we'll be moving both the indexes by one step ahead, and if these are not true, then we'll simply return false. So this is the case for the recursion approach. Now since the constraints were here till 20 only, we'll be simply be able to get it accepted here. So let's try to submit it as well. So we have this solution of the recursion. Let's try submitting it. And as you can see, it runs fairly enough, but it runs in 411 ms because of the recursive stack space involved and the depth of the tree. So this will be the approach, means the brute approach for this problem. And as we can fairly know, since the states that are changing here are I and j only. So to optimize this approach, we can simply, instead of, since we'll definitely get some problems, some similar subproblems, for example, if we have the remaining string as I to n and j to m, then we'll definitely get some same subproblems. Hence we can define the dp state as dp of I comma j and store the result that we are calculating, means that we are simply returning, to store it in this dp state. Okay, then we will simply be able to solve it in n cross m time. Okay, so the recursive means solution was important here, and then converting it to optimize it using dp is pretty easy or standard. So what we'll do, we'll simply create a dp of size n plus 1 m plus 1, because I can go till n and j can go till m. And what we'll do, we'll call, means at each step before storing the results. So let's see, means we'll memorize the solution basically. So we will, this return that we are returning, we'll simply store it in our dp of I. And here we'll check if dp of ij has already been calculated, we'll simply return the result. Initialize this with -1 dp of this. So let's see, only 1-2 line additions will be there in this code. So let's see the code. So the same code is there. We just initialize a dp of size 21 cross 21, and what we do, this is same, this is also same, and this is also same. Only this part and this part is extra here. And we calculate the answer here so that we can finally update this answer here with the value that we have got. So instead of returning, we are storing the answer in the answer that we'll get here. So everything else remains the same. We have just memorized the solution so that we can reduce the time complexity required. So now the time complexity will be simply 20 into 20, which is like very fast. Okay. So this is the the recursive means the memoized solution for this approach. Let's try submitting this solution as well and see. Initially it ran in 400 ms and now it runs in 1 ms, obviously because of the almost constant time unload. And maybe we know we can simply convert this approach. Means if we have any approach, we can write the memoization function, we can simply convert it into tabulation as well. So we can do that and still the complexity will remain the same only, but maybe it will run in 0 ms in that case. So I will not be discussing the tabulation approach here because the constraints here will till 20 only, so they only ask us to write the recursive solution. But I have explained the DP approach as well, and the converting it into tabulation is simpler only. So that can be done, but it is not needed here, obviously. So I hope all of the state transitions logic that we used in this problem is clear. And if you have any doubt, feel free to comment down and I will be happy to help. And please do if you need to follow Codehurdle for further videos. And yeah, thank you for watching.